so before we get into all this perpendicular talk and all that sort of stuff here, let's just kind of take a look at some of these warm-up problems. Here's our first one. Because I know, why wouldn't we want to write a proof today? Now, for the record, there's hardly any on the homework. There's not many on the homework. We get a little break today. But let's just kind of set it up here. They didn't even give me the chart. Statements, reasons. Okay, so just thinking about space, I'm just going to tell you how many steps because you kind of have limited space on your notes. This one's going to take 6 steps. So just kind of, number them out so you have room for 6 steps, okay? A is parallel to B. Given. Nobody gets the given wrong. Okay, so this is just me, I like to mark on the pictures. It's just I can't help myself. So if A and B are parallel, of course, I'm going to put the triangles on them. Usually they're in red, of course. And remember then, of course, this is our transversal, always working on the vocabulary, the one that intersects them. So we want to show 1 and 4 are supplementary. Clearly they have some numbered angles on the picture. So I'm thinking about what are my special relationships here. Well, there's a relationship between 3 and 4. Let's practice the vocab. What type of angles are 3 and 4? What's their name? Linear pair. Linear pair. There's also a relationship between 1 and 3. What type are 1 and 3? Corresponding. So I think we're going to use all of that stuff. Does it matter if I do the linear pair first or the corresponding first? No, we just have to have it all in there. So whatever. Because I circled the blue first, I'm going to do the linear pair first, I guess. So I'm going to say the measure of angle 3 plus the measure of angle 4 is 180. And what is your reason for that? Linear pair postulate. Okay, and then we circled the purple ones, 1 and 3. They're corresponding. What do you know about corresponding angles? Congruent. So I'm going to say angle 1 is congruent to angle 3. Corresponding angle. Corresponding angle. Okay, 50-50 time. Is it theorem or converse? Theorem, because we're not showing lines are parallel. It's just the plain old boring theorem. Now, of course, I'm going to scroll it up here just a little bit. Now, of course, I have to put that kind of lame stuff in here because you have an equation and a congruency statement. We need them the same style. Obviously, if they're congruent, we know they're equal. Let's just put that in. And that's just so we're all in the same style so we can, of course, solve this. All right, step 4. What's your reason for that one? Got it. Okay, eye on the prize. We want to show 1 and 4 are supplementary, and I think we're pretty close to that. Because if 1 and 3 are the same, I'm just going to swap this guy out with a 1. Because if 1 plus 4 equals 180, aren't they supplementary? Yeah. All right, so I'm going to replace angle 3 with angle 1 in that blue equation. And of course, what is that when you replace something? Substitution. And man, I think we're at it. So make sure, just a couple of things, like nitpicky things. I always have nitpicky things. Like on your quiz yesterday, some of us, there was a kind of a similar style of problem, like we left it here. What's the final line? We have to put the prove statement in as the final line. So make sure you do that. And what is the reason for the prove line, the final line? Definition is supplementary. Look how good we are at this now. Piece of cake. Got it. Okay, any questions on that guy? All right, let's then practice distance formula. Because like I said, distance formula pops up on a couple questions today. I put it on the board over there in case you forgot it. No judgment. We haven't done it since chapter 1, but there it is over there for you. I'm going to label the points, of course, x1, y1, x2, y2. Now remember, you can plug this in your calculator in one step. We just have to set it up. This is a good review too. So I'm just literally plugging the numbers in from the formula. x2 minus x1 squared plus y2, so 7, minus y1, 3 squared. I'm going to give you a second to punch that in the calculator, and you do get kind of a nice answer this time. And there we have it already. You should get 5. Too easy, my friends, too easy. So again, up to you if you need, I'm going to obviously leave it up here all day, but if you need the distance formula, it's going to pop up on the homework, just FYI, make sure you know what that is. All right, let's just practice some angle measures here, of course. Obviously, this is 90. Okay, we know that. That's very exciting stuff, I know. So they want you to find angle 3. Well, of course, if it's 90, it's perpendicular. So here's what we're going to do. Let's make our lives easy on this, right? So if this is 90, again, perpendicular, this whole angle is 90 because they have to total 180 to make the line. If this one is 72, this is 72 because they are vertical angles, okay? So now I think we can pretty easily find angle 3 because if I have 72 and this whole thing needs to be 90, how much more do you need to get to 90? 18, okay. Let's put 18 over here. Got it. So just practicing, vertical angles, all of that sort of good stuff. I threw out linear pair in there too, just some review stuff. All right, let's get into it for today. So notice it says proofs. There's not that many proofs, my friends, because we've already talked about perpendicular lines. You know they intersect in right angles. We know that. We've already used that. We're just going to see a couple of those. Really, probably the new thing I have is this first thing. The distance formula, there it is, from a point to a line. Okay, so that's what we're going to talk about to start it off with. The distance from a point to a line. The length of the perpendicular segment from the point to the line. This perpendicular segment is the shortest distance between the point and the line. So word you have to fill in, keyword, shortest. Now, when you flip the page, you're going to see some pictures here. There's going to be a point. There's going to be a bunch of lines to it. The key is for the shortest distance, you are looking for the perpendicular. Okay? So that's not really that exciting of a theorem, but there it is. Flip the page. So here's the picture. What I was talking about. So find the distance from point A, here it is, got it, to line BD, so this line. So here's the thing. If you take a look at it, there are 3 segments from point A to line BD. There's the green one, there's this red one, and there's this blue one. Now we want, of course, the shortest distance. So you just have to pick which line would be the shortest. And the key that we just talked about is it has to be the perpendicular one. So which line is the shortest from A to the purple line? The middle, the red one. So I want to do the distance between C and A. So I'm just going to jot down the points here. A is at -3, 3. C is at 1, -1. So I'm going to do the distance, or I should say, we're going to do the distance formula between those 2 points. That's going to be the shortest. You know I like to label, I can't help it. So let's just plug it in. Okay, so x2 minus x1. Now careful here, minus x1, that's really going to become a plus. We'll make it a plus in a minute. y2 minus y1, -1 minus 3. So of course I would just make this a plus. I'm going to give you a sec, punch it in. I like how quick we are. This one you do not get a nice whole number on. Round it to the 10th for me. Let me give everybody a chance to write. Because they're yelling out answers at me. I like it, I like it. I still have people writing down the distance formula. Got it. Make sure you can punch it in. Let me know if you get a different answer. But clearly, the answers have already been said. You should get 5.7, 5.7. Any questions on how to get 5.7? Okay. Let's jot that down. So, I kind of giggle because this is the hard part of today's lesson. If you're going to find the shortest distance, make sure you pick the segments that's perpendicular. I know, it's very exciting stuff. Okay, now we have all of these just like weirdo theorems where if you kind of ask me, it's kind of common sense, so to speak. So keywords, all about vocab in here. Perpendicular bisector. So that's the next thing we're going to talk about. There's nothing for you to fill in, we just have to talk about it. Now, before we get crazy and read through all of this, think about what the words mean. Perpendicular, right angles. Shocker, real shocker there. What's bisect mean? cuts in half. Wow, okay. That's what a perpendicular bisector does. It makes a right angle and it cuts it in half. Who would have thought? Okay, so just using your vocab, that's all that is. Now, more theorems, couple things we gotta fill in on this, or one thing we gotta fill in on this one. Linear pair, man, this is a mouthful. Linear pair perpendicular theorem. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So that's the one where you have to fill in perpendicular. So I'll give you a minute to write that. And let's talk about the why. Now again, I know I complain about these wordy theorems. They're very simple for something. It's so wordy and it's very easy. Because I'm like, okay, two angles form a linear pair. Yep, I'm on board with that. 1 and 2, they're next to each other, make a line. I got it, great. And it says they're congruent. Well, if they're congruent and they have to total to 180, how much is each angle? Isn't that a little bit of common sense? So yeah, they're gonna make right angles and it's gonna be perpendicular. Who would have thought it? All right, let's look at this guy. I need a bigger screen. Perpendicular transversal theorem. In a plane, if a transversal is perpendicular, you're looking at your perpendicular, to two parallel lines, got it, then it's perpendicular to the other line. Okay, so if you're perpendicular to one of them, you're going to be perpendicular to this one too, because what type of angles are these? They're right angles. What special name do they have when they're in similar location? Corresponding. Aren't corresponding angles congruent? Like we know that. They're going to be 90. Okay, so it's just all this crazy vocabulary for stuff you already know. And yes, there is yet one more theorem. One more. Lines perpendicular to a transversal theorem. In a plane, if two lines are perpendicular, you can see your right angles over there, to the same line, then they are, the one word you got to fill in, parallel to each other. So if these are both perpendicular to the same line, this line here, they're going to be parallel lines too. Okay. And we're going to see the picture on the next page. We'll kind of clarify all this parallel perpendicular shenanigans in a minute. Flip it. Questions, anybody? Okay. Oh, let's write a proof, shall we? Why not? Here we go. Cameron, Melanie, questions for me? Okay, just checking. Just to check it. All right, statements, reasons. Yeah. Okay. H is parallel to K, J perpendicular to H. Okay, and just FYI, so you kind of know how to space it. This is really just more for space than anything. This one's going to take us 6 steps. Just FYI, so I feel like I need a longer thing. All right, so I'm taking a look at the picture. H is parallel to K. Okay, all right. So they got the triangles on there. That's great. I like it. J is perpendicular to H. So you can see that they put this right angle on here. Now, we need to probably get specific and put that in our proof that angle 2 is 90 degrees, the right angle. Maybe the next line. And of course, they put that right angle symbol on there because what from the given? The parallel or the perpendicular? Perpendicular, definition of perpendicular. Now, there are a lot of angle numbers up here. Like they numbered everything. Clearly, we're not using all 8 angles, okay? Now remember our theorem. If we can show that this angle is, of course, congruent and perpendicular to this one, then, of course, these lines are going to be perpendicular also. So I'm kind of zeroed in on this angle 6. Now, what type of angles? What is their special fancy little name? Angle 2 and 6. Corresponding. And what do we know about corresponding angles? Congruent. So I'm going to say next, angle 2 is congruent to angle 6. Corresponding angle theorem. Got it. Now, this is, the lame step as always. We have this in an equal style and this in a congruent. So I do need to swap this one into equal style. So I'm going to say measure to equals. And I know that's just tedious and obnoxious, but we got to do it. Okay, definition of congruent. So let's see where we're at here, because I feel like we can maybe tie some of this together. 2 is 90, 2 equals 6. Oh, okay, if 2 is 90 and 2 equals 6, what can you say about angle 6? Angle 6 is also going to be 90. So again, it's really like we canceled out those matching angle 2's and wrote down what is left, transitive. And man, I think we're pretty much, we're there. Because remember what we're trying to show. I'm trying to show, and I kind of scrolled up the picture, that your line J is perpendicular to K. Well, aren't these lines going to be perpendicular since that's a right angle now? Yeah. So I'm going to say J is perpendicular to K. And you're always welcome to use the perpendicular symbol, obviously. You don't have to abbreviate it. And definition of perpendicular. You have a right angle, that's what makes them perpendicular lines. So really, this is a very long, crazy, fancy section for stuff you already know. You know perpendicular makes a right angle. We know that. We know perpendicular lines make right angles. We've used it. It's not that exciting. I'm going to tell you, I hate this picture because I don't think the right angle symbol's copied hardly at all on yours. Can you see them in the picture? Like mine's in red. Can you see them? Okay. Because I know, like, when I first looked at mine that's all in gray, I was like, man, you can hardly see the right angles there. So make sure you can see that. So photo shows the layout of the neighborhood, blah, blah, blah. Determine which lines, if any, must be parallel in the diagram, and of course, explain your reasoning. So here's the thing. We have all of these lines. There's 1, 2, 3, 4, 5 lines in this picture. 3 horizontal, the 2 vertical. So of course, I'm looking for the perpendicular piece of it, okay? So right away, I see like these perpendicular angles on here. So I'm looking at these lines. Now, just like that last proof, if these, of course, are both 90 degrees, they're congruent, the lines are perpendicular. So those purple ones are going to be parallel. I feel like when I write an S, it looks like a 5. Now, there's some other parallel lines in here because of the perpendicular part too. Because I'm looking at now P and Q. Because I see the perpendicular there, I see the perpendicular here. So since you have that perpendicular, it also makes those lines parallel. Now, I haven't put anything yet down about U, line U, the bottom one, because, do you see any right angles on line U anywhere? So it's out, it's nothing, okay? So if they're perpendicular, remember, it also makes them parallel. All right, we got it. Let's do this. You can cross off